All right, today is Tuesday, March 16th. All right, and so we're going to be looking at the factor theorem and what it means. So two questions that we're going to look at today, looking at synthetic division to find all the zeros. So how can I use synthetic division? Do you remember doing synthetic division? It was back in Unit 1. We have a box, I've got numbers, I add, this is my remainder. We'll do some review. And then how do I find all the solutions given one root? So solutions for any polynomial function are where the graph touches the x-axis. So these are my x-intercepts, also known as roots. So if I give you one, can you find the others? So in our notes from yesterday and Thursday, we factored to find the factors and then solutions, but today we're going to use synthetic division to find. So I'm going to divide to find the factors. So if you think about, like, in terms of a number, if I want to find the factors of 30, I can do division to find them. So if I know 2 is a factor, then I can say 30 divided by 2 is 15. So 15 is a factor. And then if I take 15 and I divide it by 3 and I get 5, then 3 is a factor and 5 is a factor. Right? And then I can also use 30 and 1 as factors. So we use division a lot to find factors, but now we're going to do it for polynomial functions. So do you remember how to use synthetic division? We're going to review. All right, so we're going to use synthetic division. Let me get rid of all my other papers behind. I'm going to use synthetic division to divide x to the 4th minus 10x squared plus, minus 2x plus 4. So if you recall with synthetic division, whatever I'm dividing by, we set it equal to 0. And then I solve for x. So if x plus 3 equals 0, subtracting 3, my x value is negative 3. And I put this in my box to the left. Then next to the negative 3, I write all the coefficients of the polynomial that I'm dividing into. Please be careful to make sure that you account for any missing terms. So this is missing an x to the 3rd, so I can think of it as a 0x cubed. So my coefficients are 1, 0, negative 10, negative 2, and 4. I'm going to add underneath my constant, my last value. This will always be my remainder when I do division. So I bring down and I multiply. So first number to bring down is 1, then I multiply it by what's in the box. I always multiply by what's in the box. Negative 3, bring this down, then multiply by what's in the box. That's going to be a positive 9. Then bring down a negative 1, multiply by what's in the box to move it over. That would be a positive 6, which would give me a 4 here, multiply by what's in the box. I feel like I did something wrong here. All right, I found it. Negative 3 times negative 1 is a positive 3, not 6. And then bring down a 1, negative 3 times the 1 is negative 3. And so I get a 1. So my quotient for this problem is, and I always go down 1 degree from what I started with. So when I divide by a linear factor, we always go down by 1. So this is going to be x cubed, x squared, x to the 1st, my constant, and then if I have a remainder. So I have x cubed minus 3x squared minus x plus 1 plus my remainder 1 over my divisor original x plus 3. Synthetic division. We're going to do a lot of it. If you don't like synthetic, you can always go back to long division. I prefer synthetic, so I will be doing synthetic division instead of long division. All right, so 2 vocabulary words that we've talked about a lot: factors versus roots. So a factor is what I multiply together to get the polynomial. So these are examples of factors. So when I ask you to factor something, you normally have parentheses. So if I wanted to, let's say, factor x squared minus 4, then x minus 2 and x plus 2. These two items are the factors. So if I multiply them back together, then I get my original. So my factors are what I get when I factor, and then they're what I multiply together to get my original. A root is a solution. All right, so it's what the x values equal. So after setting your factors equal to 0, they can also be called zeros or, as I said, solutions. So if I wanted to find the roots of this x squared minus 4 up here, I can factor first. X minus 2 and x plus 2. I'm going to set this equal to 0 because I do need to have some sort of an equation to solve. And then I set factors equal to 0 to solve. So x minus 2 equals 0 will give me x equals positive 2. X plus 2 equals 0 will give me an x value of negative 2. These are my roots. So factors are what I multiply to get the original. The roots are where my graph is touching the x-axis, and I can just solve my factors to get the roots. But on the test, if I ask you for factors, I want this. If I ask you for roots, I want these. So again, there's the difference. Okay, so back in Unit 1, we used, we could get the remainder using long division or synthetic division. You are going to become a bigger fan of synthetic division because we're going to do it so many times, it just goes quicker. All right, the last number using synthetic division is your remainder. Right, so I have a box here, I've got numbers. This is always my remainder. So we want a remainder of 0. So if I have a remainder of 0, that means that the polynomial or the factor goes in evenly or can be divided by. So we don't want a remainder other than 1. So if I go back to this problem here, x plus 3 had a remainder, which meant that it's not a factor. This doesn't go in nicely into this using division, right? So if I look at my example of 30, and I say 30 divided by 7, this is going to give me a remainder. So 7 is not a factor of 30. So if my remainder is 0, then it's a factor. If my remainder is anything else, then we don't have a factor, and we throw it away and we do something else. So the factor theorem is kind of what polynomials are all about. And it's kind of what I just said here with the number 30. So if we do division and we have a remainder of 0, kind of a big deal, when we plug in a number or we do synthetic division, that is a root into some function, then x plus or minus that is a factor. So essentially saying synthetic division, did I get a 0 remainder? Then it is a factor. And that it is going to be this x plus or minus whatever that number is that I use with synthetic division. So getting factors will help us find other factors. So got a couple examples here. So determine, yes or no, whether x plus 2 is a factor of x cubed minus x squared plus 2x minus 4. So if I do division and my remainder is 0, if yes, then it's a factor. If no, then it's not a factor. So let's do some synthetic division. If my x plus 2, if I set it equal to 0, then my x value is negative 2. So that's what's going to go in my box. And then my coefficients. I'm not missing any terms. It's always good to check before you get started. So 3, negative 1, 2, negative 4. So here is my remainder value. So I'm going to bring down my 3. multiply by -2, and I get -6. Add together here and get -7. Times my -2 will be 14. Add together 16 times the -2, and I get -32. And I get a 36 here. So this has a remainder. This has a remainder. So I can say that x plus 2 is not a factor of f of x equals 3x cubed minus x squared plus 2x minus 4. So my answer is no. So I like to look at the graphs and see what happens. So if x plus 2 was a factor, then that would be where it crosses the x-axis, because I can take a factor and set it equal to 0. So my factor theorem says that if it's a factor, then my remainder is 0, and I can get a solution. So since this isn't a factor, because it had a remainder, -2 is not a solution. And a solution is where a graph crosses the x-axis. So I have typed in my equation to show you that it does not cross the x-axis at -2. So here's my original equation. I'm going to hit my graph. -2 does not cross the x-axis. For my x value of -2, it's got some negative number down here. So it does have an x-intercept at +1, but I was checking for -2. And even a bigger deal, we'll talk about this in the future, if I look at my table and I look at my value of -2, do you see what the y value is? -36. What was my remainder? -36. Is that a coincidence? We'll talk about that in the future. So table can show you, the graph can show you it does not touch the x-axis at -2, but you do have to show your work with division. So let's look at our next example. Is x minus 6 a factor of this polynomial function? So I'm going to set x minus 6 equal to 0. So my x value is 6 for the box. I'm looking for a remainder of 0. So my coefficients, I am missing a term. I'm missing an x squared. I like to identify that first before I just go out with all my numbers. It kind of helps make sure that I'm not missing anything, because it will affect your answer. So 1, -6, 0, -4, 24. All right, here's going to be my remainder. Bring down my 1 times 6, 0 times 6 is 0, 0, 0. So -4 times 6 will be a -24. Whoa, look at there. So my quotient, always one less. So this is x cubed, this is x squared, this is x, this is my constant. Get to my remainder. My quotient is x cubed minus 4. But my big picture, x minus 6, is a factor of f of x equals x to the 4th minus 6x cubed minus 4x plus 24. So that means if I graph this, it touches the x-axis at 6. So let me type this equation in to my handy-dandy calculator. Here is my equation. Make sure it matches. Let me hit my graph. It should hit the x-axis at +6. Come on back. Come. Oh, look at there. So it happens to touch the x-axis somewhere between 1 and 2, and also at +6. If I was a little bit unsure about that, I could look at my table. So second graph to get my table. And at +6, I have a y value of 0. What was my remainder? What's that y value? We'll talk more about that in the future. Okay, so what if we have something like 3x minus 2? Can you use synthetic division with something like 3x minus 2? And the answer is yes. So I just need to set it equal to 0. So if 3x minus 2 equals 0, I can add 2 to both sides. So 3x equals 2, and then I can divide both sides by 3. So 2/3 is the x value that I'm looking for. So in my box, I'll have 2/3, and I'll have my numbers here. So my promise to you, if I give you something with a fraction that needs to go in the box, the numbers down here will be divisible by 3. So maybe I have 12. I can multiply 12 by 2/3 and get a whole number. Maybe it's 15. I can multiply 15 by 2/3 and get a whole number. Maybe it's 36. I can multiply 2/3 by 36 and get a whole number. So I guarantee you, it doesn't always happen in the real world, but in our world, if you're using a fraction, these will be numbers that you can multiply the fraction by to get a whole number. So if you don't, then there's a mistake somewhere there. Okay, this is what the factor theorem is all about. I want to find factors. Where are you? Just kidding. So if x minus 1 is a factor, I want to find the other factors. I'm looking for 3 total linear factors. X is to the 3rd power. It has 3 solutions. So I'm looking for 3 linear factors. If I ask you to find the linear factors, then they're going to be linear factors. So I'm going to do division. So kind of like I did with that number 30. If I knew that 2 is a factor and I wanted to find the other ones, then I said 2 into 30 is 15. And then I looked at 15 to find the rest of the factors. So I'm going to do division using this x minus 1 factor into this to get a smaller polynomial. So 1 in the box. My coefficients, I'm not missing any terms. So 3, 8, -3, -8. I'm going to do some synthetic division. My remainder has to be 0. They told me that x minus 1 is a factor. My remainder has to be 0. So I'm going to go quick. All right. So my factors for this polynomial are what I divided by, x minus 1, and then what I got for a quotient. So this started off as x cubed, so these are going to be 1 degree less in my remainder. So x squared plus 11x plus 8. All right, so I found one other factor, but I need 3 linear factors. So here's 1. Let's see if this can break down. It's a quadratic with 3 terms. So I'm going to make a product sum chart. Please be careful because we do have a leading coefficient. No, we don't. Ooh, I forgot my leading coefficient. Goodness, so sorry. 3x squared plus 11x plus 8. Hopefully you saw that before I did. So I was missing my leading coefficient of 3. All right, so for my product, I need 3 times 8, which is 24. And then my sum needs to be 11. Did you find the numbers? It's 3 times 8. Now, my factors are not x plus 3 and x plus 8 because of my leading coefficient. I take those numbers and I divide them both by 3. Always divide by your leading coefficient when you're doing your product sum chart, when you have a leading coefficient. If it was just 1, it's kind of not super exciting. But this does reduce to be 1 over 1. So that's going to be 1x plus 1. This does not reduce, so this bottom goes up front. So bottom's up, this goes up front, so I have 3x plus 8. And then I'm going to copy down my x minus 1. So again, 3 and 8 multiplied together give me 24. 3 plus 8 gives me 11. Divide those two by your leading coefficient, which is 3. Otherwise, you won't get the 3x squared plus 11x plus 8. So reduce if possible. Bottom number goes up front. So I was looking for 3 linear factors. Here are my 3 linear factors. These 2 are my answer because they're looking for the other factors. So I had the x minus 1 already. Here's my other 2. Maybe you noticed that I could factor this by grouping. Did you notice that? It does factor by grouping. So let me just show you how I can factor by grouping and get the same factors. So 3x cubed plus 8x squared minus 3x minus 8. Let me group it. We're gonna group it. All right, so out of this first group, I'm going to take out an x squared, and I'm left with 3x plus 8. So this is a negative 3x to a negative 8, so I'm going to take out a negative 1, and I'm left with 3x plus 8. These turn into one factor, x squared minus 1, and then I have a 3x plus 8. Yeah, look at that. And then this is a difference of squares, and I can factor into x plus 1, x minus 1 times a 3x plus 8. So we get the same answer, right? So I want to start off with one that I could do in either direction, or with factoring or with division to find the other factors. But in the future, I will give you ones that won't factor by grouping. Okay. All right. I've got two more examples to go through. So here I have, given that x minus 2 and x minus 3 are factors of this polynomial function, I want to find the remaining factors. I'm looking for 4 linear factors. I already have 2. So my answers factored out will be x minus 2 and x plus 3. There should be 2 more linear factors. I just have to find them. If you look at this polynomial function, I can't do a product sum. There's not a special pattern, and I can't group because I have an odd number of numbers. So I have to do division. I'm going to end up doing division twice. Once with an x minus 2 and once with an x plus 30. So since they give me 2 factors, I'm going to use synthetic division twice. It doesn't matter which one you start with, but when I do division the second time, I'm going to take the quotient to do division again. So I'll show you what I'm talking about. So if I put 2 in the box here, then my coefficients, I am not missing a term. So I've got 2, 7, negative 4, negative 27, and negative 18. So my remainder needs to be 0. Bring down my 2 times 2 is 4. Bring down 11 times 2 is 22. Bring down 18 times 2 is 36. Bring down a 9 times 2 is 18. Hey, remainder's 2. So this is 2x cubed plus 11x squared plus 18x plus 9. Looking at this, if I group these together, an x squared comes out and I'm left with 2x plus 11. If I take out a GCF here, it's 9, that's 2x plus 1. So this does not factor by grouping, even though it has 4 terms. But it does factor using synthetic division. So I am going to do synthetic division using this other factor of x minus 3. So put my negative 3 here. I'm not going to go back to the original. I'm going to divide by this. So let's think about the number 30. If I do 30 divided by 2, I get 15. If I want another factor, I can take 15 and divide by 3 to get 5. So my factors would be 2, 3, and 5. If I divide back to the original 30, I'd have a large number and I'd have to do division again with this 2. So dividing by the quotient will save you time and help you find the factors faster. So if you have to do synthetic division twice, do it the first time with the original, and then when I do synthetic division the second time, I'm going to use the quotient, because then I'll have an x squared. So coefficients 2, 11, 18, and 9. My remainder needs to be 0, so that I have, or show that x plus 3 is a factor. So bring down my 2 times negative 3. Bring down a 5 times negative 3. Bring down a 3 times negative 3. Boom. Remainder of 0. So this is 2x squared plus 5x plus 3. This is going to give me 2 factors. These 2 factors are going to go here and here. Since I have a quadratic with 3 terms, I can make a product sum chart. So 2 times 3 is 6, and my sum needs to be 5. So I need 1 times 6 won't work, but I can do 2 times 3, because 2 plus 3 is 5. So with these numbers, 2 and 3, I need to divide them by my leading coefficient, which is 2. This reduces to 1 over 1, so that's going to be x plus 1. And then this is going to be 2 bottoms up, so 2x plus 3. This is my answer for the 2 remaining factors. All right, one more. Similar to this, here I gave you factors. For this problem, I'm telling you that 10 is a root. 10 is a root, and I want to find the other factors. If 10 is a root, then I can say 10 is a solution. And if 10 is a solution, then x minus 10 is a, do you remember what it's called? Factor. So I have one of my factors because I took my root and I subtracted it from both sides of the equation. If I have x equals 10, move it over. So 10 is a factor. So if it's a factor and a root, then I can do synthetic division with it. So 10 is going to go in the box. Looking at my coefficients, 4, 3, 2, 1. Oh, I'm missing my constant. You have to include the constant in synthetic division because it's a missing term just like any other term. So 1, negative 12, positive 12, 80, and 0. My remainder should be 0 since 10 is a root. Here we go. Hey, it worked out. So x equals 10 is a solution. So if I look at my list of factors, x minus 10 is a factor. I'm looking for 3 more because I had x to the 4th power. So I need 3 more. 1, 2, 3 for my other factors. This equation is going to give me the other factors. So I started with x to the 4th, so all of these go down by 1. So I need to look at x cubed minus 2x squared minus 8x plus 0 and factor. 3 terms, I can product sum, but I do have a GCF in this problem. It is x. So if I take an x out, then I'm left with x squared minus 2x minus 8. So x is a factor. I was looking for 3. There's 1, and this will give me 2 more when I break it down. In my product sum chart, my product is 1 times negative 8, which is negative 8. And then my sum is negative 2. So I need 2 times negative 4. My leading coefficient here is 1, so not super exciting. But I do have x plus 2 times x minus 4 for this quadratic. And those are my other 2 factors. So I was given 1 root and turned it into a factor. These are my other 3 factors. You can always check to see if your factors are correct by multiplying them back together. If I multiply all 4 of these factors back together, I will get my original polynomial function. Thanks for watching.